This is Dr. Coil Fix. Today we're back on another interesting edition again on why does car AC compressor magnetic clutch coil bond. As you're seeing this one here, you can be able to tell this is for two different make. This one here is for Denso, and this one here is some other Denso, but for Mercedes. So in this today edition, I'm going to be explaining to you why this clutch coil get burned, so you know exactly what you're dealing with. If you're new to my channel, you might want to subscribe to my channel, because even if you don't subscribe, in as much as you're looking for AC problem fix, you're still going to be going back and forth within my channel, because so far I think I have so much talked about car AC issues, much more than so many other channels we have right there in the YouTube, including fixes and what have you. So if you've done that, sit back, relax, and don't forget to give us a thumbs up, because we're gonna be opening this guy's ass today. So the number one reason why this compressor clutch get burned cannot be overemphasized without talking about these other two sets here, the clutch as much as the magnetic clutch, as much as the pulley. So you have to understand how these two works before you can know why this clutch coil here get burned. So you have three assemblies altogether. You have a 10mm bolt here that hold it in place, that tight right to this very shaft. Now let me show you the one I have burnt. So you look at it, it's pretty much toast, like I see if someone got a barbecue, you know. So you can see how terrible it's roasted. So why does it get burned? It get burned due to many reasons. You can see the second one again. I have two. I have some of them, a lot of them that are burned. So I have a lot of coils here, so you can take a look at it and see for yourself. It can actually get burned due to excessive friction in the system. I repeat, excessive friction in the system. And that is why I say you can't talk about the clutch coil burning without emphasizing, without knowing how this two works. Now, this one here can be stationary. This is the only part that is stationary. Why this bearing moves this one, and it moves with your drive belt or your serpentine belt. As it moves, this one here has to be magnetized by this guy here when a 12 volt to 14 volts of power is being fed into that coil right there. Now, if there work on the system before, there are a couple of things that can actually cause it. The gapping between here and here, the space between this here and here, that is often being created by a little spacers that are inside this very place here, is what can actually increase the gapping. So if the gapping is too much, it's gonna cause this coil to fry, and if it is too small, it's gonna cause this coil also to fry. So you have to stay within the premium range which the manufacturers have set for it. So you need to look out for the range for your own car make and model. Now when it gets sticked right there, most often times it can get burned. The clutch coil can get burned without the clutch. The clutch also get burned with it. So in most often times when the clutch get burned, is often as a result of friction too, because when this started, you can hear that, when this continued to be in that, continue to wobble, why this flywheel is moving at 1000 to 3000 rpms, while this one is stationary, keep on maintaining a friction here that makes it to keep rubbing on it here. What's going to happen is these two parties are going to start generating excessive heat, and when it starts generating excessive heat, there is a rubber here, and this rubber here, we quickly say, oh, these two guys fighting, I didn't cause it, and I don't know how you guys started it, but wait, I can't be here. This rubber is actually put in place so that you can be able to make a spring. Yeah. Okay, so this guy is gonna say, this rubber is gonna say, whoa, I'm not here, so I gotta give you guys a chance. And most often times it get roasted because it's not metal, so the two metals get clashed up. And let me show you what it looks like when this rubber get torn apart. Just a moment. Okay, this is what it looks like when the rubber is surrounding this very place. So when it's been roasted and the rubber jump off and say, no, I can't join this fight, this one is separated. So technically speaking, this one is here. You can see it right there. That's the side that holds the shaft. The same thing here. The difference here is that the rubber is still holding this one in place. So due to that excessive friction between here and here, it generates a lot of heat, enough that it roasts this rubber off. And within those time where it's roasting that rubber off, that is when this very one here, because this surface here has been protected by rubber, so it's also get roasted. This coil also get roasted along with it, and that is what causes this coil to fry. So the gapping of these very two things here is very important. You can't touch it and can't be too far from it. If it is too far from it, it's not going to magnetize. Even if it magnetizes, it's still going to burn. If it is too close, that is rubbing it while this pulley is busy moving, as it's moving right now, then it's still going to cause the same problem. So maintaining the right position, the right gapping is the most important crucial decision you need to make when you arrive at this very destination here. Then another thing that can also cause the other thing that can also cause this coil to fry is overcharging, system overcharging. When you overcharge the system, it's going to create too much pressure on this very clutch here trying to turn. The first thing it's going to be trying to deal with here is to destroy the clutch, and if it couldn't be able to do that, the force of magnet there is going to be holding it strong and trying to allow it to spin, but the pressure inside this compressor here that is building on the high side is too high, that is now creating a resistance on this clutch and trying to stop it not to move. But at the same time, in as much as there is 14-volt power being fed through this coil, through the wire here, it's gonna still be trying to hold it in place. So it's a tug of war. Your engine power is gonna be pulling this pulley very hard, and the magnetic coil is going to be holding this clutch in place to keep moving with it and moving the compressor. And the power that will hold that clutch there is this magnet, is this coil induction that is being energized by 12 or 14 volts. So within that time, there is a high pressure inside this compressor that is trying to resist this clutch not to turn and the coil not to turn, the clutch not to turn. But at the same time, there is a huge power. It could be V8, it could be V12, it could be V16, it could be V32, all the V goddamn that you can find in the world, trying to pull this pulley with your belt or serpentine belt to move it, because it can't stop the engine from moving once you start the engine. So at that, there is going to be a huge repulsion to the motion of this very clutch right here due to too much refrigerant in the system overcharging. So at that, quickly it's going to be targeting the rubber here as much as the coil here, because that repulsion that is repelling it is going to be creating a very huge setback, react back on this very coil here, and that's going to roast this coil. Now the next thing also that's going to roast this coil is lack of oil in the system. When there is lack of oil inside the system, think of it like running your engine. I've said it oftentimes, time again, why compressor overheats. When there is no oil, little or no oil inside the system is going to be, getting warmer inside there and creating a friction not to move, but this is going to be trying to make it move. So at that very position there, the first thing is going to be damaging here is the clutch. That is, if the gap is correctly set, it's going to damage the clutch. When it damages the clutch, it's going to face the second phase. The second phase there is, think of it, when it damages this clutch, Now there is no more rubber pulling it, so this one is going to go right in there and get stuck with it and rubbing body to body right there. So when it does that, it will heat up this thing and it will transfer the heat to the coil, and that is how your coil gets burned. So guys, I hope you find this very helpful to solving the problem regarding your compressor clutch coil getting burned or your compressor clutch getting burned. This is Dr. Coil Fix. I hope to find you in the next episode. I'll catch you later. Bye for now. Don't forget to subscribe, share with your friends, and give me a thumbs up.